Okay, now it is asking us to find the particular solution. So what I was trying to explain in part B is they talk about the particular solution, so it's important that you understand again that there is a curve, there's some equation for the curve. They are calling that equation y equals something or f equals something. There's an equation for calculating all the slopes on that curve. They call that dy dx, just like this box is illustrating. And then we went and found a third equation, this tangent line equation. So that was all part B. Now in part C it does say, find the particular solution. Go find out what does y equal, or what does f of x equal. So now we have to use the SASSY method. Again, with the SASSY method, I have typically found that getting the first 4 points goes fast. It's the last point that can take a while, so be a little careful about whether or not you try to get the last point. So multiply both sides by dx. Multiply both sides by 1 over y squared. Now we have separated the variables. If you have that red statement, you get 1 point. Okay, now we need to anti-differentiate. Be careful here. We don't have a rule for the antiderivative of 1 over y squared. That's not the ln rule. So you're going to have to change it to y to the negative 2, because we do have a rule for y to the negative 2. This integral antiderivative here will require the expanded ln rule. So this is going to become y to the negative 2 plus 1, all divided by negative 2 plus 1, equals, okay, this is 1x minus 1. So this is A, this is B when you're using the rule. So it's 1 over A, natural log, absolute value, ax plus b, plus the constant. If you have the purple statement, you get another point for finding both antiderivatives. Okay, now we're going to constantate. Okay, let's fix this. This is y to the negative 1 divided by negative 1. Dividing by negative 1 is the same thing as multiplying by negative 1. So we have this equals natural log absolute value x minus 1 plus a constant. Okay, y to the negative 1 is the same as 1 over y. So I'm going to rewrite this as 1 over y equals natural log absolute value x minus 1 plus c. And now I'm ready to plug in. So we'll move this all the way up here. The y value is 3, the x value is 2. So you get 1 over 3 equals natural log absolute value of x subtract 1 plus c. That's 1/3 natural log absolute value of 1 plus c. Natural log of 1 is, this is equal. Natural log of 1 is 0. So I figured out that c is equal to 1/3. If you plug in the values, which is what I did here, that's 1 point. If you correctly find c, that's another point. So now we're at a total of 4 points. Except I did make a mistake. Apparently it's not good for me to do videos in the afternoon. Somehow I lost a negative. Oh, right here. So right there is a negative. Okay, last step is to do the isolation step. So that means we're going to come back to this equation here. So we're going to copy this over. And erase all this. Okay, so we're starting with this equation here. So we have negative 1 over y equals natural log, absolute value of x, subtract 1, minus 1/3. Just need to get the y alone. So multiply both sides by y. Which means you're going to get all of this times y. Don't need to do simplification, so it does help. Now we simply divide both sides by this whole thing, and we're done. So you get negative 1 all over, natural log, absolute value. So this is a case where the isolate step went quite quickly, so it was probably worth continuing, or if you went ahead and then came back, you'd be pleasantly surprised, of course, to find that formula. Don't forget, that's the formula for finding all the points on this curve. That's what I call f right here, just like they did. They called it f of x or y, it doesn't matter which. That's how we find all the points on this curve. The formula they gave us initially is to find all the slopes on that curve. The tangent line equation is to find points on the tangent line. So one more point for the isolate step for a total of 5 on that problem.